Hey guys, I'm here today. We're working on the next part of describing data with numbers. And the first thing I want to do is talk to you about a homework question I thought was kind of interesting. It's question number 85, talking about baseball team salaries. And I wanted to go over this with you because it wasn't something we'd really discussed, but it really kind of hits home whether you understand what the idea of a mean is. If you can read from the question, take the mean and the sample size, and get the total amount. And also kind of use that context. You have to understand what is total annual payroll, and you have to fit that context into the math equation that you're given for mean. Okay, so here they tell us that the mean yearly salary for its players is 1.2 million, and the team has 25 players on it. So if you want the total payroll, that's going to be the total amount of money that all the baseball players are paid. So that is going to be, if you look at the formula in red that I've drawn here, so I can get the right pen, here we go. Then I've said, okay, our mean X bar is equal to the sum of all the data values divided by the sample size. Well, let's think about the things that we have, and we could almost treat it like an algebra problem. We could take our formula for mean, plug in the information we know, and then solve for what we don't know. And so let's see what we know. Let's do green. We know the mean. We know that's 1.2 million. And I'll leave it in millions for now. We don't know the sum of all the data values, and this is actually what we're going to try to find. This would be the annual payroll. It'd be the sum of all of the players' salaries, and then our n is our sample size, and that's going to be 25. So here we have a really simple algebra equation. If we want to solve for the sum of x sub I, right here, then all we have to do is multiply both sides by 25. And that's what I've done up here. 25 times 1.2 is 30, so the total annual payroll is going to be $30 million. And then it asks why you can't use the median to calculate the total annual payroll, and I've kind of given an explanation, and it's really just because the median just shows position. It doesn't show anything about the total. And because we have to use the total in order to calculate the mean, that's why we can extract that from the information, but we don't need that total to calculate the median, so we can't get that information if we're just given the median and the sample size. Okay, so let's think about what we have left to describe today. We have done mean and median. We've done the 5-number summary along with all the quartiles. We've calculated outliers. So today we're going to take that 5-number summary and we are going to calculate or create a box plot, which I think you probably did in Algebra 1, but I could be wrong. And then we also are going to take that or we're going to kind of step away and talk about a different number that can describe data, and that's what's called standard deviation. We are going to use the calculator a lot today, so if you haven't gotten a calculator, make sure that you get one. And we're going to start off by putting some data in the calculator. So everybody get a calculator out. If you need to pause the video, go ahead. Okay, so here what we have is we have Barry Bonds, and we have his baseball record, or the number of hits per season, right? Home runs per season. And what we're going to do is we are going to take a look at all this data and we're going to create a box plot for it. So in order to create a box plot, what you need to do is you need to first find the 5-number summary. That's what it says. So start by sorting the data so we can find the 5-number summary. So we're not going to use the sort function on our calculator because we have an easier way to do 5-number summary than that. We are actually going to use a function on the calculator that'll just spit the numbers out for us. But before we can do that, we want to take all this data and put it in the calculator. So pause the video, go ahead and take this data right here. You can either read it off the board or you can look at your paper. Put that in L1 in your calculator. If you've forgotten, we've slept since the last time I made you put data in your calculator. Let me remind you very quickly. Remember, we use that stat button because obviously it's a statistics class, so we use the button a lot. And then you just hit enter on edit. And then let me remind you how to clear your list out so you don't screw up and delete the list. I'm going to go all the way back up. Here we go. Okay, hold on. All right, so you should be here. What you're going to do, let's do this first. So in case you forgot, I'll go back and start over from the beginning. So we're home. This is your home screen. So if you would like to put data in your calculator, you press stat. You hit enter on edit. All right, so now we're all together. So I want to clear out what's in L1 so I can put that data in L1. So I go up and I highlight the list. I press clear. Remember, we don't press delete, we press clear. And then I hit enter. And my list is cleared. All right, so take that data, input it in your calculator, have someone check and make sure that you have inputted it correctly, because if not, we're all going to end up with funny numbers. They're not going to match. You're going to be confused. So when everybody gets done inputting the data, restart the video, and we will go on to find our 5-number summary. Okay, I'm back. I put my data in. Hopefully you are back and you have put your data in. And now we can calculate the 5-number summary, make sure it matches up with theirs. I'll show you how to make a box plot. So I'm going to hit stat. I'm not going to sort my list. If you have gone ahead and sorted it, it's not going to hurt. It's going to be fine. It's going to give you the exact same 5-number summary. But what we're going to do is we're going to go over to calc, because we want to calculate this 5-number summary. And what we're going to be using today is this first function, 1var stats. So we have stat calc. I'm going to take a screenshot of this. And then I'm going to paste it. Come on. Oh, here we go. Over here, so you'll remember if I did this correctly. Let's see. Yeah, here we go. Okay. So this right here is what we want. This 1var stats. This is what we're going to be working with all day. And we're going to go back to my calculator and I'm going to hit enter on 1var stats. And then I'm going to tell it what list my data is in. So remember, we have our list names above all these numbers. L1 is above 1, L2 is above 2, and so on. And we're going to press second L1, and then I'm going to hit enter. And I have run my 1-variable statistics on L1. Now we have lots of things here that we could talk about. We're not so interested in all of them. I will point out right now here is X bar at the very top. Let me take a screenshot of this so I can write on it. There we go. Oh well. There we go. Okay, so this right here that's highlighted is your mean. That's what we did yesterday. The next one down, I'll do this in varying colors so you can see what I'm talking about. This is just the sum of all your data values. So if you took all those home runs, that's the total number of home runs that Barry Bonds hit over his 21 seasons. The third one is really not important to us at all. We'll do that in blue. That is the sum of all your data values squared. And we actually will never use this class, so just forget about the sum squared. And then the last one I'm going to do in pink, this we're going to talk about in just a little bit. This is your standard deviation. And then we actually, at this point, are not interested in this right here, although we will deal with it later. So this right here, this that I'm marking out, and then what's in green, we don't need any of this. For this screen, really, we just want the mean and we want the standard deviation. All right, so I'm going to go back to my calculator because we want to go down. See, it has this little down arrow over here. That's what we're interested in. So if we go all the way down to the bottom, notice my 5-number summary. I showed you what this was last class. So I have my minimum, my Q1, my median, my Q3, and my maximum. So remember that. Don't think, oh, I screwed up. I don't have my 5-number summary when you go and run your 1-bar stats. Remember that you just have to scroll down. Always forget. You know. So this is what we want. And if we wanted to go up and check it against what they have, we would see that we got the exact same thing. They got the minimum is 16, Q1 is 21.5. So that's our minimum at 16. Oh wow, that's fun. Q1 is 21.5, my median is 34, Q3 is 35, and my max is 73. So I got the same thing for all of them. Okay, so I'm going to kind of go through this picture here and show you how to make a box plot. So what I always start with is my box. All right, so I'm going to kind of recreate this so I can draw it for you. It'll make it easier for me to teach. And we're going to do this example later. If you want to do it on a separate sheet of paper so you have more room to write notes, that's fine. I lost my mic, sorry. Okay, so what we start by doing is we start by making our box. We also want to label our axis. So I know I'm going to go from 16 all the way to 75, 73. So I'm going to go 15, 20, 25, 30, 35, 40, 45. I'm going to need a much bigger axis to go all the way to 75. So let me rethink this. Let's do 10, 20, 30, 40, 50, 60, 70. That'll work out better. Okay. Sometimes I gotta think when I'm making an axis as to how to do this correctly. So let's do 10, 20, 30, 40, 50. I'm gonna run out of room again. 60. I can do it. 70, 80. I can just pull it down a little. There we go. Okay, so I'm going to start by making my box. My box, if you look up at the example, is going to go from Q1 to Q3. So the left side of my box should be at 25.5, and this is pretty approximate when you're doing it by hand, so don't stress about making it perfect. And then it's going to go all the way to Q3, which is 45, so I have this right here. And then it's just a box. The vertical height of the box means absolutely nothing. So I could make a box this tall, or I could make a box this tall, and they mean the exact same thing. I don't care how tall your box is. There is no y-axis on a box plot. We're just looking at one variable data. All right, so now we make our little tails. So our first tail is going to be all the way to the minimum. So we have a minimum at 16, so I put a dot at 16, somewhere about right there, and then I make a tail, or a line from the dot to the box. I mark a vertical line at my median, which is 34, so that would be about there. And then I go all the way. I mark a little hash. If you notice, it's not a dot like it is on the other side. It's just a little hash at my maximum. And then I draw a line all the way from the box out to the maximum. So here's my minimum. Here is my Q1. There's my median. There's my Q3. And there's my maximum. Now, if I give you a set of data and I ask you to create a box plot for me, what I would like for you to do is I would like for you to write out your 5-number summary. Now, I have mine listed here from my calculator, but just so I know that you got the correct 5-number summary and you didn't screw something up. So you could just off to the side, because I'm not making you do it by hand, so it's a little easier. So you could just say Minimum is 16. Uh-oh. My red pen is not and I are not working together. Let's try green. My Q1 is 25.5 and so on. Now, I would like for y'all to work this example number 92, but I would like for you to, hold on, lost my train of thought. Okay, so, sorry. It says here, be sure to check for outliers. I should change the color. I don't know. I hope y'all can read that. And plus it's pink. It's kind of pretty. Okay, so what happens is if you make a box plot and you have any data that are outliers, you can create what's called a modified box plot. And a modified box plot, instead of marking the vertical lines all the way out to the minimum and maximum, they put little stars where they're outliers. And this allows you to see where the normal pattern of the data stops and then where you have outliers. So let's, with this data, very quickly check and see if we have any outliers. I'm interested to see if this 73 is an outlier, the one that he got all the famous awards for. And then I think they found out he was taking drugs, but I could be wrong. I don't know. I don't keep up with sports. Okay, anyway, so let's calculate outliers. So we are going to do 1.5 times our IQR. Our IQR, let's do that up here. Remember, is Q3 minus Q1, so that's 45 minus 25.5. Okay, and we get, oh wow, I screwed this up. Sorry. Oh, it's up here in the example. Ha ha ha. So we get 19.5. Okay, so 1.5 times my IQR is going to be 1.5 times 19.5. And we get, oh, they don't tell you exactly what this is. Oh well, we'll just do the math. 1.5. 29.25. Okay, so now we're going to do Q1 minus 29.25. Q1 is 25.5. And so that's going to be something that's negative. So it's not going to matter. Negative 3.75. And then let's check and see if we have it on the upper end. So Q3 plus 29.25, my 1.5 times my IQR, is going to be 45 plus 29.25, which is going to be 74.25. So it's not an outlier. It was really close, but that 73 is not quite an outlier. So we made our box plot correctly. If it were an outlier, what we would have done is we would have taken the largest number that wasn't an outlier, which would have been 49 if you looked at your data, and we would have ended our little stick at 49. So we'd have taken this to 49 and then stopped it. And then we would have put a star out here at 73. And this is how you do what's called a modified box plot. If our 73 would have been an outlier. Now in this case it wasn't, so this isn't really correct. But alright, so pause the video. I want to see how y'all do on number 92, and then we'll come back and I'll show you the answer. Okay, so I put everything in my calculator and I ran my 1-bar stats. I hope y'all thought to do that first. And I got my 5-number summary. I checked for outliers, and I did actually have 2 outliers. These 2 students that just did horribly on Miss Lou's test. Lou, I don't know, whatever. On Miss Lou's test. And so I marked them as stars. The next highest value was 72, so that's where I put my dot. You can see I labeled everything here for you. My Q1 was 82, Q3 was 87.75, my max was 98. My max was not an outlier, so I marked that with my little stick. And then this said, how did the students do on Mrs. Lau's first test? Justify your answer. And I said I thought that all of the students scored fairly well, as to be expected. You don't expect all A's, but you would expect them to all follow a fairly symmetric distribution, which is what you have here. You can tell that the distribution is symmetric because your box plot is symmetric. You see, you could fold it in half and it would match up if you didn't have those two outliers. So the two outliers definitely scored way more poorly than the rest of the class on the exam. Okay, so let's talk about standard deviation. I think I've been talking too much, so I should probably move a little more quickly. Standard deviation is pretty important to us. It measures the average distance from all your observations to the mean, kind of an average. It's like a meh average. And I'll tell you why in just a few minutes. Here is your formula right here. When it asks you to calculate your standard deviation by hand, I find it's easiest just to use this formula. Generally, they're not going to make you do it for 20 data points, maybe like 4 or 5. And by the end of class, I showed you already how to find standard deviation on your one-bar stats. And so you will actually have to answer some questions where you just plug it all in and run your one-bar stats on the calculator. All right, so how we get standard deviation is we first calculate what's called the variance. And this just shows the squared distance from each observation to the mean. And it's all it is the same thing that's up here except without the square root. So if we took away the square root, then this is what you'd get, is you'd get the first data value minus the mean. If it's average distance from the mean, we're going to take all those data values and subtract the mean from them, and then we're going to square it. And the reason that we square it is because if we just look at some positive and some negative distances, sorry, that didn't make sense. If we look at all the distances from the mean, some of them will be positive and some will be negative. And so if we added them all together and divided by the sample size, we would get 0. So what we do to get rid of that, kind of taking the absolute value, but without doing it that way, is we square all the numbers, all the differences, and then we take the square root later. And this kind of counterbalances for us and gives us a number that's not 0. Okay, so you have your two formulas for standard deviation and variance. Before I give you these things you need to know, I want to go over to the next page. And I want to take a look at this example because it kind of goes through exactly how to calculate standard deviation by hand, and then we will go through and I will talk about interpreting and all that stuff when we finish going over this. Okay, so here we have we have some data. This is the number of pets owned by a group of 9 children. So if we're going to calculate the average distance from the mean, the first thing we want to do is calculate the mean. Fairly simple. So then what we want to do is we want to look at all of the differences, the distances from that value to the mean. And so what we're going to do is we're going to take just how the formula looked. If you see what I'm circling in red, take all those data values and subtract the mean. Now notice if you took all these numbers and you added them up, you would get 0. Because they're all distances. The mean is the middle point. So every single time that's going to be 0. So because of something kind of beyond the scope of this course, we don't use absolute values. If you know anything about calculus, it's probably because it acts funny around 0. You can't differentiate it around 0, but that's way beyond this course. You don't need to know calculus. So we don't use absolute value. We square all the numbers and it makes them all positive. Okay, so I I'm going to kind of write this out using the actual formula because I think it's easier to do it this way than to make this big table here, especially if you only have a couple values. So it would look something like this: 1 minus 5 all squared plus 3 minus 5 squared plus 4 minus 5 squared plus dot 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 all the way to the end. And then we actually divide this. We're trying to find the average. So generally, an average, you divide by the number of values there are. In this case, we actually don't want to divide by the number of values. We want to divide by the number of values minus 1. So we divide this by 9 minus 1. And once again, I hate to say this twice in one conversation, but the reason we divide by n minus 1 and not n is kind of also beyond the scope of this course. When we talk about later different types of distributions, we'll talk about this thing called degrees of freedom, and the degrees of freedom is the reason why we divide by n minus 1, but it would be a whole nother lesson to explain to you what it means. So right now, you're just going to have to trust me, take the formula, and use it. So what I have here, if I would have taken this all the way out, the dot, 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 is I would actually have the variance. Because if we flip back over and look at this formula, no, wrong way, sorry. Then what we have here is we have all of those data values minus the mean squared, and then we divide it by n minus 1. And this is my variance. So once you get this number, you could say, hey, this is my variance, and then you can take the square root of it to find your standard deviation. Notice that my variance is just the symbol for standard deviation squared. So standard deviation is an S with a little x as a subscript. And then our variance is just the standard deviation squared, so we put a little superscript of a 2 up there, and this is variance. Standard deviation, if you can't read it on the paper because it's kind of small, is S sub x. That's the letter, the symbol for that. All right, so let's go back over to the next page and go back to the example, and then let's see how they calculated standard deviation. So they took that 6.5 they got by adding all of those squares together and dividing by 9 minus 1. They got 6.5. And then they just took the square root of it. And so my standard deviation is 2.55. So this is about the average distance of each one of those data points to the mean of 5 pets per person. All right. So let's go back. Now that you kind of see what standard deviation is, what it means, let's talk about first interpreting it. So these are going to be things you need to know about standard deviation. Let me go to black. Okay, so interpreting. So remember, when we interpret something, we always include what it means. So we would say the average distance for, from each point to the mean, and then we include the context of the problem. So when we interpret, we would say Sx is the average distance from each data value to the mean. But don't forget to include context. Okay, so here's a few other things. Your standard deviation is always going to be greater than 0. And this is because you're adding up a bunch of values that have been squared. And if you remember anything about algebra, then if you square something, it's always going to be positive. So you're adding a bunch of positive numbers together, you're dividing by a positive number, you're going to get a positive number in the end. Plus it's a distance, really. Distances are positive. So your standard deviation has the same units as your original data. And then lastly, think about what we talked about last class about resistance or not being resistant to outliers. Think about if you had all of those pet owners and then you threw in somebody who, with that crazy cat lady who lives down the street from you that has 25 cats. And you threw that into your data set and you calculated the standard deviation again. Then you're going to have one really large distance from your that 25 to the mean. It will change the mean some, but that distance will still be really large. So when you use that distance to calculate the average distance, it's going to change the standard deviation fairly significantly. So we would say that the standard deviation is not resistant to outliers. So now we have two things that are not resistant to outliers, mean and standard deviation. No, drop my paper. Okay, so, sorry about that. So now let's go over to the next page and see what we have. So we're going to talk about the calculator. So we are going to, let's do this. I need to pull up the notes from yesterday so that we can look at this data. So let me find these notes. If you have them, you can pull them out. We want the data, I think it's on the second page of the notes, because we want the travel times for New York and North Carolina, I think it was, that we talked about last class. And then we're going to calculate mean and standard deviation and all that stuff with that data. And that's what this technology corner is. That's the data that they're working with. All right, so yesterday was Unit 1, Day 3. Okay. And it's the second page of those notes. Okay, come on, Smart Notebook. Sorry, it's being ridiculously slow. Why don't y'all go ahead and get out your calculator and clear out list 1. And if you have that data on your desk, if you have your notes from last class, go ahead and put in, let's do, let's see. It says in here, North Carolina is going to go in L1, and New York is going to go in L2. So go ahead and start that. Let me pull this data up. And then y'all can pause the video and you can see the data, and then I'm going to have to pause it so I can put this data in my calculator. Da, da, da. All right, here we go. I think it's on this page. We can see both of them. Okay, so here you have both sets of data, right? One here and then one there. So take this, pause the video right now so you can see it all, and then put all that in L1 and L2. Remember, this is going to go in L1, that's going to go in L2, and then I'll come back to you in just a second. Okay, so here I've taken and I've put all this data in my calculator. So I'm going to get rid of this. I don't need that anymore. And then I'm going to go back to this technology page over here. And I mean, we've pretty much done this. I showed you how to calculate standard deviation on the calculator, but let's go through it again. You actually have a couple homework questions. So we put all the data into L1. You don't have to order the data, just put it in there as it is. And then remember how we do this. So you press Stat, we go over to Calc, we hit Enter. And if we want to find the average and standard deviation for North Carolina, which is going to be what's over here on this left side, as well as the 5-number summary, then what we're going to do is we're going to take and we're going to put second 1 because our data for North Carolina is in L1. And then we're going to hit Enter. All right, so now we have our mean. Our average driving time is 22.47. We have our standard deviation is 15.23. And then if we wanted our 5-number summary, we could scroll down and get our 5-number summary. Fairly simple. All right, so now let's take and let's do this same thing for New York and find the average for New York and so on. So now we're going to press Stat, go over to Calc, hit Enter on 1-bar stats. Our data for New York is in L2, so we press second 2 because there's an L2 above 2. So kind of redundant. And we hit Enter. So we get our X bar, our mean is 31.25. Our standard deviation is 21.88. And if we wanted the 5-number summary for that, we could scroll down also. Oops. Come on, work for me. There we go. Sorry, and then we scroll down. And there's our 5-number summary. Easy enough. Okay, so what I want y'all to do right now is there's 3 examples on the next page. Flip over to those. They shouldn't take you too long. The longest one's probably going to be 105 because you're going to have to input all that data into your calculator. And then pause the video, work these out, come back, and we'll go over the answers. Okay, so, oops, wrong example. Try again. Okay, so what we've done for the first one is we've calculated the standard deviation by hand. And what we've gotten is the first thing I did was calculate the average, because you have to know that to calculate standard deviation. Then I went through and I did my standard deviation. I subtracted, or actually I did variance first. Sorry. And then, so I subtracted the mean from all the data values, squared them, and divided by n minus 1, and I get 1.3 as my variance. I take the square root of that number, if you'll see down here, and that gives me my standard deviation. And then I interpreted it. So it's going to be the average difference and the amount of sleep from the average. So I said average difference from the average. I guess I should have said from the mean, but anyway. So I said what it is, and then I used context. I said amounts of sleep. I didn't give you C. This is kind of an iffy question. I don't think it's safe to conclude that the mean is 8 hours. One of the things is that you actually don't have a data point that's 8 hours. So if exactly half your class slept 7 and exactly half the class slept 9, then 8 hours isn't a very good estimate. Just because nobody slept 8 hours. So there's lots of things you could say for part C. The next question is pretty self-explanatory. They just want you to read those graphs, give the highest, the lowest, the median, and then say what's different. And obviously one set of data is much more spread out than the other. And then the last one they wanted us to, or we were going to put all the data in and then use our calculator to find the mean, the standard deviation, and the 5-number summary. I think that I kind of screwed this up here. This should be mean, and then this should be standard deviation. I don't really know why I don't have it written that way. Okay, so y'all work on the Unit 1 Day 4 homework, and then next class we're going to do Unit 1 Day 5. And then the next class you're going to have a quiz over Unit 1 Day 1 through Unit 1 Day 5. And you'll also do a little activity. Next class's lesson is pretty short. I just have one more little thing to go over about describing distributions. And then y'all are going to get together and work some review problems. So make sure that you come ready to review next class. You come with any questions that you might have over any of the material. Talk about it with your peers. Email me if you have questions, and then be ready for that quiz after that. All right, we'll talk to y'all later.